Around the globe, data is everywhere, growing exponentially.
Data powers entire businesses.
Fueling industries with insights, knowledge, and opportunities.
We've been on a mission to help organizations mobilize their data with the Snowflake Data Cloud.
Now you can break down silos of data, uniting teams across your business.
You can share data with suppliers and partners to drive decisions.
And tap third-party data instantly.
To gain new insights and a competitive edge.
When you have the full story, you can serve your customers in entirely new ways.
The Data Cloud is redefining your industry.
Helping realize your company's vision.
Empowering you to build the future.
By bringing data
together
now.
Hi, welcome to this presentation about how we at PlayStation have scaled our platform to handle increasing data volumes. My name is George Livingston. I'm responsible for data engineering, infrastructure engineering, architecture and service management and support within the data strategy and operations team. I'd like to take you through our experiences to date. So, areas I plan to cover today. It's going to be a brief introduction to Sony Interactive Entertainment and the team I work in, data strategy and operations. I'll go through a little bit of detail about previous state. I'll then move on to how we scaled the platform. I'll cover off the end state architecture, and then I'll finish on the learnings that we've encountered along the way. So, in terms of introductions, Sony Interactive Entertainment. This slide only goes back to 2013, but at that point we launched the PS4, and we already had around about 80 million PS3s worldwide. Moving to 2016, at that point 50 million PS4s had been sold. And by the time we get to 2019, there are 500 million PlayStation devices sold worldwide, 90 million of those PS4s. Last year, the PS5 launched, and we've sold more than 10 million PS5 units to date. So this slide gives some idea of the number of hardware devices. What it doesn't talk about is the subscription and the network elements to the business. It also doesn't cover the game studios. So there's an incredibly complex ecosystem behind these device numbers that has been created and is managed by Sony Interactive Entertainment. Moving on to the data strategy and operations team. Team are comprised of a number of groups. There is a data sciences capability, so people that are building predictive models, looking at propensity forecasting, those sorts of things. There are also people within the DSO team that provide insight to the rest of the business. The team also build dashboards, self-serve reporting capabilities as well. Cloud infrastructure is another team within data strategy and operations. Architecture comprised of solution architects, data architects and a cloud architect. Data governance, so a team that are responsible for the correct usage of the data that we make available. a data engineering team responsible for coding the routines that process the data that comes in, and a product management team that ensure that we're working on the highest priority items that deliver the biggest business value. So moving on to the next section and covering the sort of the previous state, a very simplistic and high level platform overview here. Data obviously comes into the platform, and that is a mixture of telemetry events, events from server-side components, and so on, quite large volumes. That's picked up by the data processing code, which cleanses, transforms that data and applies any business logic. So anything that adds additional context to the data. The data is then loaded into the enterprise data warehouse, and then sitting over the warehouse are various reporting and analytical tools. Obviously at this point everything is on premise, so we had a number of issues in this area. We were struggling or unable to easily add capacity to our compute layer for the data processing. At the data warehouse layer, we were both compute and storage constrained. Increasing demand was being made of the data warehouse, both in terms of the data that we were loading into it, but also the increasing usage being made of the assets hosted within the data warehouse by our end users. The DBAs, as a result, were spending more and more time creating more and more elaborate workload management rules to sort of squeeze the best out of the warehouse. And as it states in the bottom couple of bullet points, we're a relatively seasonal business, so we see high demand at periods like Thanksgiving, Christmas and so on, but we couldn't easily flex to manage that. We're also reliant upon other internal teams to make any infrastructure changes. Now, whilst they supported us really effectively, they were also supporting a number of other teams. Also added to the problem was the fact that data volumes were consistently rising. The earlier slide I showed depicted the number of devices being sold, increasing user base. So more and more data was coming onto the platform. We're also seeing more and more use being made of data sciences, and certainly that was relatively compute intensive. And as the business expanded, the number of end users increased. So more and more people using the platform to make better decisions using data. So at this point, it was pretty clear that a fairly radical change was required to handle increasing volumes, increasing usage, and our general inflexible nature of the platform at that time. So, given all of the constraints on our previous platform, we embarked on this 2-year technical refresh. This was split between some areas that were a sort of a lift and shift, i.e. limited changes were required to get the code or the applications working in cloud, versus some areas that were a complete rewrite to run in cloud. So the aim of this was to deliver a next generation data lake, a data warehouse, and a completely new data sciences tooling stack. So taking each of these work streams in turn, the data lakes team was responsible for collaborating across the company to work on a unified data lake across Sony Interactive Entertainment. to make more effective use of data. Another work stream was responsible for migrating the data processing routines into the cloud. This was largely a lift and shift, so not that many changes were required, although subsequently we have, or the team have made some significant changes there by using technology like Kubernetes. The MicroStrategy migration was the group of people that were re-platforming MicroStrategy, so the tool, or one of the tools we use for business intelligence and analytics. That requires fairly substantial changes to work more effectively in the cloud. There was also an effort around migrating to a new data warehouse. So this was moving from existing IBM Netezza data warehouse appliance to Snowflake, a cloud warehouse. This was a significant undertaking. I have more information on this in a subsequent slide. We also needed to create an in-house sort of cloud systems and operations team. So in-house capability needed to build, maintain, monitor the cloud environments. The target operating model was a small work stream, but really important. And they looked at the non-technical aspects of a move to the cloud. So, for instance, how to handle cost control. What should we, or how should we manage things like security? How should we apply tags so that we can identify our cloud instances and so on? So really critical piece of work there to ensure that the transition to cloud was as effective as possible. And then finally, the data sciences tooling area was a separate team responsible for completely rewriting the data sciences stack. So moving from things like, or technologies like IBM SPSS to Spark with Jupyter as a notebook tool. So moving on to a very high level view of the plan to migrate to Snowflake. This was a really complex undertaking. Many reasons for that complexity. For instance, the data was constantly changing, so we're continually loading more and more data into the platform every day, and so there's never a point at which it's static. Also, we had to extract the data from the existing appliance, but do that in a way that didn't cause too much disruption to the users that were currently using the existing platform. It was quite tricky to get that balance right. Towards the end of this migration, there was a parallel run phase where we were trying to keep both data warehouse appliances in sync. We actually tried to keep this period as short as possible. It was really operationally intensive to make sure that there were no reconciliation issues between the two. And when there are thousands of load routines happening each day, it's quite easy to get things out of sync. So that was kept quite brief, or as brief as we could possibly make it. The end result of this was a migration to Snowflake, which was very successful. No severity 1 incidents, and actually we managed to close the project a couple of weeks earlier from a warranty period perspective due to the lack of issues. So I've covered our previous state and how the platform looked before we started the migration. Now moving on to the end state or current state architecture. So again, very high level view of at a technology level. So in the left, we've got tools that we use for data processing or integration, as it's stated there, Ab Initio and Spark. As I mentioned earlier, we're now running a number of our ab initio nodes on Kubernetes. We're using Airflow for some orchestration. So for instance, when end users want to schedule SQL scripts or jobs, they will use Airflow for that. Snowflake is our data warehouse. So within that we have, I think, over 40 virtual data warehouses, split based upon either the business unit using them or the function that they're performing. For instance, accepting loads. We have, as I mentioned, Spark and Jupyter Hub form the bulk of the data science capability. And then from a CI/CD perspective, we're using Terraform for our infrastructure as code capability, with Ansible at the application layer. Underpinning this layer is various AWS services that I'm sure many people will be familiar with. So we're heavy users of S3 for storage, MapReduce for our Spark compute, and Kubernetes, as I mentioned, is being used for data sciences purposes, but also for data processing. So moving on to some of the benefits of the end state. The team have tested the platform up to very, very high volumes of data, so many billions of events each day. So from a data consumption perspective, we're confident we can handle pretty much anything that can be thrown at the platform. We are also able to add and remove capacity easily, and actually we're devolving that responsibility down to the Scrum teams, so they can do that themselves. They can provision the compute or the storage that they need based upon the requirements coming into them. A big problem that we previously had was contention between usage types. So for instance, on our old data warehouse, we would have business unit A competing for resource with business unit B. Because of the way we've set things up on Snowflake and isolated the business units, we just simply do not have that contention anymore. We're also in control of cost, and we've managed to maintain a pretty constant cost profile despite volumes increasing fairly substantially. And one way we've done that is by using spot instances to for some of the worker nodes on the data processing clusters. And then finally, instantiating the infrastructure as code means that recreating it is relatively straightforward and repeatable. We're confident we can always get back to a good end state. So some of the learnings we've experienced on our migration to cloud are articulated on this slide. First of all, acknowledge that teams may be approaching things in a different manner. So for instance, a team that is doing a complete rewrite and using completely new technology may approach things differently than a team that is doing perhaps a lift and shift and trying to reconfigure application or technology to work in the cloud. Really critical in our case to get strong stakeholder buy-in. We had to lower the amount of business delivery throughout this period we could achieve, and that needed stakeholders to be accepting of that, and we had to be very clear about the benefits that they would see. So some of the things I talked about earlier around the ability to scale the platform without issue. There also needs to be a focus on the non-technical aspects. I think it's sometimes quite easy to get caught up in only focusing on the tech side of things, but some of the work done around sort of process change, covering things like, whether approvals would be needed to start new instances, how we would identify and tag instances, were really, really critical to make sure that our sort of experience in cloud was as successful as it has been. And then finally, we found it really beneficial to train up the existing team in cloud. They know the applications that we run. They understand the data. They understand our stakeholders. That means that we're able to configure the infrastructure to ensure that the applications run in a really optimal manner. So really important. And then some learnings from running Snowflake at scale for last couple of years. Really important to think about how to segregate the workloads and how to organize them between the virtual warehouses. Do you split your customer groups by warehouse, or do you look at the workloads you're running, for instance, data sciences or data loads, and split accordingly? Or do you do a hybrid of the two? We also found it beneficial to start small, very straightforward to make a warehouse larger if needed, if you get feedback from a customer group. But we found it quite a good idea to start small and then increase capacity based upon feedback. Really good idea to think about how you're going to handle change from Snowflake. Do you need a separate environment? Also, if you have stakeholders that have created a lot of their own code, SQL code, whatever it may be, how do you ensure that their scripts, their code, their components are able to be tested against any changes coming through from Snowflake to make the product better? We also found that education of end users is really important. So features like cloning potentially means end users need to change how they do things. So potentially stop using create table as statements, but move to clones. Also things like educating users that cancel queries still cost. So sort of bear that in mind about how potentially SQL is constructed. Also, we found a good idea to keep an eye on storage. It is possible to keep multiple copies of an object. So something that we regularly monitor and keep a close eye on. And then finally, we found that the role of the DBAs changes. So actually, they become quite focused on looking at cost, ensuring that the warehouses are the right sizes, and how to enable things like data sharing. Is there security model that the warehouse is designed around? Does that enable easy and effective data sharing? So changing focus from that perspective. So in summary, the last couple of years has seen the DSO team move from on-premises to a completely cloud-based architecture. The platform's now able to handle the ever-increasing data volumes and also the usage demand being placed upon it. And Snowflake has offered us a more scalable and flexible approach. It has improved customer experience and has allowed us to segregate workloads, so we have no contention between customer groups. Thank you very much for your time today, and I look forward to your questions in the Q&A session. Thank you.
to wait. Got my. Are the guys there? They are. Hi there, welcome. So we've got a new person joining us. It's Jason Miles, here you go, and George Livingston. So we've got a few questions for you guys. The first question is, did you make use of Snowflake features such as eternal files and Snowpipe, or have you just replicated the previous warehouse? Not sure who that wants to answer that.
I can take a stab at that. So we're not currently using Snowpipe. I didn't catch the name of the first feature you mentioned.
External files and Snowpipe.
Was that eternal?
External files.
External files. Okay, yeah, sorry. So, yeah, so we are. So apologies. Yeah, so we're not using Snowpipe to load. We had to make quite a few changes to our load processes to load into Snowflake. And I think as well, what we did is we created a separate load warehouse for the ETL jobs to load into, so that there wasn't the contention with warehouses used by other customers or for other workloads.
Okay, and the other question I
had. I don't know.
So the next question was.
Sorry, I was just going to see if Jason had anything to add about.
Sorry. Did you want to add something, Jason?
No, that's
all right.
That sounds all clear.
Okay, good. Next question was, what has the biggest amount or biggest effect on the data amount? COVID or a launch of PS5? I would probably say COVID. A bigger install base of PS4 than PS5, but certainly PS5 has had an impact. I think generally you find as things move on, as generations change, people want to find out more information about how the devices are performing and being used. So probably COVID, I'd suggest. And did you need to hire more people or different skill sets to do all this?
So we didn't really. So we had some help from an external consultancy to move to Snowflake. So they sort of brought in a few people to supplement the team. Generally, in terms of our move to cloud, we retrained quite a lot of people, so people that previously worked in the team. We did also hire several people that had been using cloud externally. I think I said in the presentation that certainly retraining people in the existing team has really benefited us. They're people that understand the workloads, that understand the applications, and then it's just a question of applying that to cloud.
And the other question I have is, what infrastructure as code tools do you use for Snowflake? What infrastructure as code tools?
So for Snowflake, we're not, for infrastructure as code, we're using Terraform for the infrastructure components. So everything that sits below the applications. And then for applications, we're using Ansible, so everything coded in that sort of way. We are looking. We currently have a sort of an in-house tool that we use for database change, and we're trying to figure out whether we should continue augmenting that, or perhaps look for a sort of a different tool. So something that allows you to deploy changes to database objects effectively, track changes, understand impacts and lineage and so on.
Lovely. Well, and a question for
Jason,
both of you.
if you've got a perspective on a good tool there. Oh.
Jason? I think.
Can everyone hear me?
Yes, yeah, we can. Go for it.
Can everyone hear me okay?
Yep.
Yep.
I mean, yeah. So basically, the common, so Terraform and Ansible tend to be the main sort of tooling that are, I mean, there's lots of other tools that are native to Azure, for example, AWS, but yes, but Ansible and Terraform are very common tools that we see.
Great, thanks guys. One last question, a little bit off topic, but what's the best thing about working for PlayStation, apart from free PlayStation?
I mean, it's I suppose it's a bit corny, but I'd definitely say the team. It's a great set of people working on really challenging problems. Very bright group of people. So yeah, I think the team, the environment. Obviously, we're all, as I am now, working at home. So that's been slightly more challenging as for a lot of people. But certainly, yeah, I think the team, this sort of environment, and some, as I say, very big challenges based upon sort of volumes of data and how to squeeze the best performance out of the sort of the code that the teams build. So yeah, difficult engineering problems, but a bunch of really motivated and interested and bright people, I think is probably what I'd say.
So it's the people for you. What about you, Jason? What about you, Jason? What's the best bit about working for PlayStation?
Sorry, I didn't hear the last part of the question.
What's the best bit about working for PlayStation?
Oh, you know, I first of all, you know, everyone at Sony, both, it's a global organization, right? So we know a lot of the contacts in the USA, here in the UK, and other areas. But you know, we really love working with the team. They're very dynamic. As George talked about, they're addressing ever increasing volumes of data on the Snowflake platform, and they've got a very large, complex environment. I think George mentioned about 45 virtual warehouses dedicated to business groups or function. But yeah, it's a great organization, very dynamic. They're pushing and innovating on Snowflake. And you know, I have a PlayStation, so when I'm playing, it's great to see how they use the data to notify me of things and things like this. It's very, I would say, yeah, just a great organization to work for and a great team.
Lovely, thank you guys. None of you said the free stuff, but appreciate it. Thank you so much. Well, that's all we got time for with this one, but our next session is at 1:30. Find out how Europe's largest bank, BNP Paribas, uses customer data to accelerate its marketing efforts. See you then.